So welcome back, Stella. In this video, we are basically going to start the exercises. So where you see the stars, those are the exercises I'm going to do. So for the first part, I'll do this, sec, cosec, this, and this. While doing this, when I will be doing these two ones, sec and cosec, I will directly prove this, what they ask us to prove here. Yes, this I will directly prove these other things. So I'll also do for part two, I'll do this exercise. I'll do what again? Don't be afraid of all this. They are very simple, very simple. I'll do what again? Yes, on part three, I'll do this one because I will need to tell you what kind of substitution you are supposed to use here. Whenever this bottom is linear, when I talk of linear, it means that the powers of trigonometric functions are 1, 1. Yes, and the top is linear. I'll also do this one. What should I do again? I'll do this other one. Yes, this type. And I will end up by doing this last one. Okay, so without wasting time, let's move into our stuff. Let's start with this one, the integral of 1 all over 3 plus cos square x. So exercise on type 4 part 1. Okay, let me go to the next page. Exercises on type 4 on integrating rational functions. Okay, so the part one, the question 1, I'm supposed to integrate 1 all over 3 plus cos square x dx all over 3 plus cos square x dx. Okay, this is the integral I'm supposed to do. Okay, we see that this integral is already in the form, on the form what? Integral of 1 all over what? A plus b sine square x sine nx sine square nx plus c cos square what? Nx. Is that okay? So I will say that the substitution in such a case is t must be equals to what? Tan nx. So let's proceed without wasting time. So I will let my t to be equals to what? Tan nx. What is our nx here? Our nx here is simply what? 1 times x. That is, let t to be equals to what? Tan x. I don't know if you are trying to get what I'm saying. Okay, from here I will directly find the x. I'll first of all find the x. This implies I differentiate this will give dt because I have 1 times dt. I differentiate this implicitly. So this, when I differentiate this, the derivative of tan x is what? Sec square x dx. I multiply by dx because I was differentiating with respect to x. I'll write back this sec square as 1 plus tan square x times dx. Okay, so I make x dx the subject. Dx will be equals to what? Dt on what? Will be equals to dt on what? 1 plus tan square x. But remember, our t was equals to what? Tan x. This implies dx will be equals to what? Dt on 1 plus t squared. That's already our dx. The next thing we have to do is what? The next thing we have to do is that I have to bring out this triangle because I know that t is equals to what? Tan x. That's it now. So let me bring out my triangle. From that triangle, I will deduce what? Cos x. I will deduce the values of cos x and sin x. So let me draw my right angle triangle. My angle is what? X. So this tan x being equals to t is the same thing as t on 1, which is opposite all over what? Tan x is opposite all over adjacent. So what is the side, which side is opposite to the angle x, which is here? It is this side. So this t, we're going to place it here, and the side that's adjacent to x is what? This side. So this one will come here. So this will naturally be what? Using Pythagoras theorem, it is the square root of 1 square plus the square root of this 1 square plus this t square. Okay, I'll call this A, B, and C. Okay, in this integral I'm finding, I need to find what? Cos x, because I'll need to substitute it there. So from triangle ABC, I have what? I have cos x being equals to what? Cos of this angle is equals to what? Cos is adjacent over hypotenuse. So 1 all over what? The square root of 1 plus t squared. Is that okay? Okay, now having find the cos x and the x, I will not substitute directly. I first want to have the simplified form of this expression below. So this implies, I have my cos x, it implies 3 plus cos square x will be equals to what? Will be equals to 3 plus what? Cos x. I know that cos square x is the same as cos x all that square. So this will be 1 on root 1 plus t square all that square. This will be equals to what? 3 plus 1 all over what? Because 1 square is 1. All over 1 plus t square. So this implies 3 plus cos square x will be equals to what? So let me simplify this. So this will be 3 into 1 plus t square plus 1 all over 1 plus t square. This gives this 3. This is 3 times 1 plus 1, 4 plus 3t square all over 1 plus t square. Perfect. So this is what we're supposed to have. So this will be equals to 4 plus 3t square all over what? 1 plus t square. Perfect. Okay, let's move. Okay, this is perfect. We have already this bottom. So this implies the integral of dx all over 3 plus cos square x will be equals to what? I substitute my dx. Where is my dx? This will be equals to the integral of, where is my dx? My dx was equals to dt on 1 plus t squared. This is dt on 1 plus t squared all over this. So this 3 plus cos square x was equals to what? 4 plus 3t squared all over what? 1 plus t squared. Is that okay? So this will be equals to the integral of what? dt on 1 plus t squared times this becomes 1 plus t squared all over what? 4 plus 3t squared. So this and this goes. This will be left with what? The integral of dt on what? 4 plus 3t squared. Now, we know how to interpret this. This, when you look at this, this is like they're asking us to integrate what? Dx on what? A plus bx squared. What would be the substitution here? Naturally, we know that the substitution that will pass here will be what? The substitution that's going to pass here will be what? Will be tan theta being equals to something. That's it now. Will be tan theta being equals to something. Very good. So let's continue. Let me write this. And to integrate this, what what we basically have to do is what we basically have to do here to integrate this. So what we have to do, remember, look at this. That's why I'm saying master your different forms. This is the same as the integral of dx on a plus bx squared. So to integrate this, we know that the substitution will be tan. We first of all have to write this in the form 1 all over 1 plus something all that squared. And from there, we shall let what? Our tan theta to be equals to what? All what is inside here. I don't know if you are trying to get me. Okay, now let's proceed. Let me wipe this. So to integrate this, I will let, no, I cannot let now. Let me first write it. Let's first write this in the form 1 plus something all that square. You get what I'm saying? Okay, let's do that. So the first thing we have to make this 1. This will be equals to 1 on 4 integral of what? dt on the, since I factorize 4 here, this remains 1 plus, since there was no 4 here, this is 3 on 4 times what? T squared. I think you understand what I'm saying. Okay, now we have to write this to the power square so as to bring it inside. So this will be equals to 1 on 4 integral of what? dt. 1 on 4 integral of dt, integral of dt, oh, pardon, integral of dt all over what? All over 1 plus root of 3 of the square root of 3 on 4, all that square times what? T squared times t squared. I hope that's okay. Okay, we're going to continue on this other side. Let me divide the paper into 2. So let me divide it a minute. So I'll continue with this line here and it goes down. Okay, now let's continue on the other side. I will then bring this root 3, the square root of 3 on 4 inside. You understand what I'm saying? Because they have already square, these two square, using the rule a to the n, b to the n equals to ab times all that to the n, lots of indices. So I will continue. This will be equals to 1/4 integral of dt all over 1 plus 1 plus, let me put big brackets, 1 plus t root 3 on 4 all that square. I hope you understood what I did. So when this comes in, it makes t times this all that square. Are you okay? So now that this is already in the form 1 plus this all that square, I can easily let my tan theta to be what? This. So I will be very careful. If at the beginning, don't use the same variable twice. When you make 2 substitutions, don't use the same variable twice. What do I mean? I mean by if in the first substitution your t was equals to tan x, don't let this what is tan x to be equals to what is inside here again. No, use another variable. So I will let my tan theta, because this is already an integration of the form 1 all over 1 plus something square, which resembles the integral of what? 1 plus t square. You get what I'm saying? And we know that this integral will give an arctan. You understand? So let me wipe this. So let theta be equals to t root 3. Wait, let me simplify again this. Let me simplify this before letting it. This will be equals to 1 on 4 integral, because root 3 on 4 is simply equals to root 3 all over 2, because this will be the square root of 3 over the square root of 4. You get what I'm saying? So this dt on what? 1 plus t root 3 on 2, all that square. Is that okay? So now I will let my tan theta to be equals to what? T on root 3 on 2. So this implies I differentiate this implicitly because I will have to substitute dt here. So this gives, when I differentiate this, it is 1 plus tan square theta. The derivative of tan theta is sec square theta, or again 1 plus tan square theta. Since I was differentiating with respect to theta, this gives d of theta, which is equals to, when I differentiate this, I'll have root 3 on 2 times dt. Okay, so this implies my dt will be equals to what? 2 into 1 plus tan square theta d theta all over what? Root 3. So now I will substitute this dt, I will substitute this dt here, and I substitute this tan theta inside here. So it implies 1 on 4, I copy back this, 1 on 4 integral of dt all over 1 plus t root 3 on 2, all that square, will be equals to what? I substitute 1 on 4 integral integral of what? My dt is, this is my dt, 2 into 1 plus tan square theta all over root 3 d theta. So I substitute, my tan theta was equals to this. This becomes 1 plus, this is tan theta, so I'll have tan square theta. You see that this root 3 will go under, and this will go with this. You get what I'm saying? So this will be equals to 2 on 4 root 3 integral of what? D theta. You get what I'm saying? So this will be equals to, these two will go with this. We're going to have 1 all over 2 root 3. Integral of theta is what? Of d theta is theta plus our constant of integration. But in what form was our integral given? It was given in terms of x. So the first thing I have to do is I will substitute what is the relationship to what is theta related. From my previous substitution, this substitution, that's what I will first use to find theta. But tan theta was equals to what? Tan theta was equals to t root 3 on 2. So this implies theta will be equals to what? The arctan of what? T root 3 on 2. So I'll first come and substitute it here. So this implies the integral of dx, I copy this, 3 plus cos square x will be equals to what? I first substitute this theta inside here, the last expression. So I'll have 1 on 2 root 3 arctan of t root 3 on 2 plus my constant of integration k belonging to r. But the problem is that our answer is not yet in terms of x. It's not yet in terms of x. We have to leave it in terms of x. So what was the relationship between t and x? If you go back here, if you come back here, you can remember that t was equals to what? T was equals to tan x. So where I will see t, I will replace by what? Tan x. So but t was equals to what? Tan x. So this implies the integral of dx all over 3 plus cos square x must be equals to what? 1 on 2 root 3. I'll write back this arctan. You know that arctan is the tan inverse. Tan inverse of what? My t must be what? Replaced by what? Tan x. So I will have root 3 on 2 tan x plus our constant of integration. So that's the integral we just found. That's the integral. So that's the integral of 3 plus cos square x. You see that it's very simple. And you notice that in this, the particularity here, we were faced where in this exercise we did two substitutions. This was the first substitution we did. Reaching at this stage, reaching this stage, where is it even? Reaching this stage, we saw that this is a type of integral we have already done previously. That is an integral of the form 1 all over a plus bx squared. We saw how to integrate it. So you see how videos are done. The videos I'm doing, they are done in a chronological way for you to understand clearly what is being done. So to integrate this, we first have to arrange it in the form 1 plus something all that squared. And since it is in this form, naturally the second substitution, the substitution we are going to do to have that is to let what will be inside here squared to be equals to what? Tan theta. You understand? And from there you proceed, and finally when you reach here, this is the final integral. The first thing you have to do is substitute theta. How do you get theta? Theta, you get theta from this. Tan theta was equals to this. So this theta, you go and substitute it inside here. So this integral will be equals to this times arctan of this plus constant k. But remember, our integral, the starting integral was given to us in terms of what? The variable x. So, and we know that at the start here, our first substitution was t being equals to what? Tan x. So where I see t, I substitute by what? Tan x. So there is a t here. I'll substitute it by tan x. So this is your integral. So I hope you kind of understood. You basically understood what was being done in this exercise. So try to do this exercise. This is an exercise that was taken in your textbook, Pure Maths Made Easy. I think yes, this exercise was taken in your textbook, Pure Maths Made Easy. I think it's on page 332. Yes, in the textbook it was not very well explained. Yes, it's not well explained, the procedure. They jumped a lot of steps, so try to go through the video and master how this exercise was being done. So let's go to the next exercise. I don't know if I should really waste time and do this. Okay, let's try it. Let's do this. 1 all over the integral of 1 all over 2 sine square x plus 4 cos square x. Okay. What is it? Okay, let me go to the next page. We are on page 54. Let me go to page 55. That's question 2. Integral of 1 all over 2 sine square x plus 4 cos square x. 2 sine square x plus 4 cos square x dx. Even this exercise, it is in your textbook, Pure Maths Made Easy. I think it's page 332 also. Yes. Okay, let's try to do this. We basically see that this exercise is already in the form 1 on a plus b sine square nx plus c cos square nx. You understand? So it's already this type of integral. So we know naturally that the substitution here must be t being equals to what? Tan nx. You get what I'm saying? Okay, so let's get into the stuff. So I'll let so I'll let my t be equals to what? Tan nx. Our nx here is what? our nx here is simply 1 times x, that is tan x. You understand? From here, I'll directly find dx. It implies my d, when I differentiate this implicitly, I differentiate this, I'll have 1 times dt being equals to the derivative of tan x is 1 plus sec square x. So I will have 1 plus tan square x, pardon, or sec square x, 1 plus tan square x. Since I was differentiating this with respect to x, I write dx. So this implies my dx will be equals to what? Dt on 1 plus tan square x. But remember that your t was what? Tan x. So this implies my dx will be equals to what? Dt on 1 plus t squared. That's already my dx. The next step, we shall do what? We first draw, we take our tan x is equals to what? T. So this is t on 1, which is opposite all of our adjacent. Let me draw my triangle, my right angle triangle. Our angle is what? Tan x. So this is our, pardon, our angle is x. So this x. What's the side that's opposite to this angle x? It is this side. So this is the opposite. This becomes t, and naturally this becomes the adjacent, which is 1. And here on the hypotenuse, we shall have 1 plus square root of 1 plus t squared using Pythagoras theorem. Okay. In our integral, look at something. There is, we have to find sine x, and we have to find what? Cos x. So from the triangle, let me call this triangle ABC. So from triangle ABC, what will be my sine x? My sine x, be very careful. I'm not finding sine x because my triangle is having x. I'm finding sine x because here inside my integral, I will have a sine x that I will have to substitute here, and I will have a cos x that I have to substitute here. That's why I'm finding sine x. So be very careful. It's not because of the triangle that I'm finding sine x. It's because of what the integral has given to us. So sine x, we can use the triangle. Sine x from the triangle is equals to 1. Sine is opposite all over hypotenuse. So I have t on the square root of what? 1 plus t squared. And naturally cos x will be equals to what? Adjacent over hypotenuse, 1 all over the square root of 1 plus t squared. Is that okay? Okay, from there, I will not substitute everything directly. I'll first calculate this bottom, simplify it well before coming to substitute. Because if I come and substitute it, I can easily do errors. Let me first simplify this easily. So we have 2 sine square x plus 4 cos square x. So this implies 2 sine square x plus 4 cos square x will be equals to what? I'll have 2 into, this is sine x, so this will be t on root 1 plus t squared, all that square, plus 4 into what? 1 all over the square root of 1 plus t squared, all that square. So this will be equals to, when I square this, I'll have a t square here. So this will make 2t squared with the 2 outside, all over 1 plus t squared, this bottom, plus this will give 4 all over 1 plus t squared. So this implies 2 sine square x plus 4 cos square x will be equals to what? 2t squared plus 4 all over what? 1 plus t squared. So we have found already this. Now we can easily go and substitute in our integral. So this implies the integral of dt all over 2 sine square x plus 4 cos square x will be equals to what? Will be equals to, I substitute my dt. Where is my dt? My dt is my dt, my pardon, oh, I made an error. This is dx. This is dx. The integral we're finding. So I substitute my dx. Where is my dx? My dx is dt on 1 plus t squared. So I'll have dt on 1 plus t squared all over what? 2 into sine square x. Oh, pardon. Let me wipe this. That's an error. So I'll have will be equals to integral of, I substitute my dx. We know that this bottom is equals to what? 2t squared plus 4 all over 1 plus t squared. Always calculate everything. You calculate dx, you find it, you calculate this apart first before coming to substitute. Because if you directly come and substitute it here, you will make a lot of errors. So always do it like that. So this will be equals to what? This will be equals to the integral of what? Dt on 1 plus t squared times what? This is divided by this, so it will become 1 plus t squared all over what? 2t squared plus 4. Are you getting what I'm saying? So this and this goes, and we'll be left with what? The integral of dt on what? 2t squared plus 4. You see that this is already an integral of the form what? Integral of the form d, let's say this is an integral of the form dx on what? A plus bx squared. So you basically have to first of all write it as what? Dx all over what? 1 plus something all that square, and your substitution will be what? Tan theta being equals to what? All what is inside here. You get what I'm saying? Exactly as we did in the first question. So let me wipe this. Let me wipe this. So I'll write this back first. Be very careful. I'll write it back. This is not what you are supposed to make 1 first. Be very careful. So I will write it back first in this one. 4 plus what? 2t squared. Okay. Now, I will factorize. What I will do is that I can factorize 2 here. 2 here, because there is a 2 that's common here for me to simplify things. That will be a half into what? Integral of dt all over what? 2 plus t squared. Is that okay? Now, what we are supposed to do is, first of all, make this to be equals to 1. Is that okay? So, a half integral of dt on 2 plus t squared. Let me first draw a line like this. Wait a minute. Let me draw a line for me to really exploit the space. Okay, so we have a half integral. So this will be equals to a half integral of what? We have dt on. I'll factorize these two. So this becomes 2 into 1 plus, since there is no 2 here, that will simply become a half t squared. Is that okay? Now we are supposed to bring all what is here inside what will be squared. So this will be equals to a half. This half will come, this is 1 on 2. So this will become 1/4 integral of what? Dt on the 1 plus square root of 1 on 2 all that square times what? T squared. We use our technique that we commonly use. Okay, now I'll bring this root 1 on 2. Since they're already having the same power, I'll bring it inside. This is dt. This will be equals to 1/4 integral of dt all over what? 1 plus, so let me put big brackets here. This becomes t root 1 on 2 all that square. Is that okay? Since they have the same power. You understand? Laws of indices. A to the n, b to the n equals to a, b, all that to the n. Is that okay? Now, we shall continue. Let me root 1 on 2 is the same as root 1 on root 2. So square root of root 1 is 1. So I'll have 1 on root 2. So I'll write back this as 1/4 integral of what? Dt on what? On 1 plus since this will give 1 on root 2, so this becomes t all over the square root of 2 all that square. Is that okay? Now, having reached this place where this is already in the form integral of dx all over 1 plus something all that square, we can easily use our substitution, our next substitution. So I will let tan theta to be equals to what? T on root 2. You understand? That means where I will see this, I will place by tan theta. Now I need to find what? Dt. What will be the value of dt? To find dt, I need to differentiate this implicitly. When I differentiate this, I'll have 1 plus tan square theta, which is the derivative of tan theta. This is the same thing as sec square theta. Since I was differentiating with respect to theta, I'll put here d theta. This will be equals to the derivative of this. I'll have 1 on root 2 dt. Okay. This implies my dt will be equals to what? Root 2 times what? 1 plus tan square theta d theta. That's my dt already. So I can now substitute everything in this integral. So this implies 1/4 integral of what? Dt on 1 plus t on root 2 square will be equals to what? 1/4 integral of what? 1/4 integral of what? Where is my dt? My dt is root 2 times 1 plus tan square theta d theta all over what? All over 1 plus this t on root 2. This is root 2. T on root 2 was equals to what? T on root 2 was equals to tan theta. So this will make tan square theta. You see that this goes with this, and we are left with what? We'll be left with 1/4 integral of what? No, root 2 on 4. Yes, because there is root 2 here. Root 2 on 4 integral of what? D theta. And the integral of d theta is simply equals to, so we are going to have root 2 on 4 theta plus a constant k, where k belongs to r. Now, our integral was given in terms of x, so we have to leave everything in terms of x. So what we have to do, recall, from here, our tan theta was equals to what? This. So we can recall that our tan theta was equals to t on root 2. So this implies theta will be equals to what? The tan inverse or arctan of t on root 2. Is that okay? So now the problem is that so this is our theta we have found. We have to come and substitute it inside here. So this implies the integral, this starting integral that was given to us. Where is it even? This integral, yes. So the integral of dx on 2 sine square x plus 4 cos square x will be equals to what? I'll copy this. This is the final answer. This theta, I come and substitute it here. I'll have root 2 on 4 tan inverse of what? T on root 2. Don't forget that tan inverse is the same as arctan plus our constant of integration. But the thing is that the answer is not yet in terms of x. But we know that this t is related to x from our first substitution. Our first substitution, which was what? T being equals to tan x. But we know that t was equals to what? Tan x. You understand? So this implies x is equals to what? X is simply equals to what? From here, no, we don't have to find x. What am I doing? So our t is equals to what? Tan x. So wherever we see t, we substitute by what? Tan x. So this implies the integral of dx on 2 sine square x plus 4 cos square x dx will be equals to what? Root 2 on 4 tan inverse of what? Where I see t, I replace by what? Tan x. Tan x on the root 2 plus our constant of integration. So that's our integral. You see that it's very simple. Very, very simple. Nothing is complicated. So just take your time. You go through the exercise. Go through the exercise and try to do it. Try to redo it yourself. It's very simple. Don't be afraid of such integrals. If you try to do everything, master your rules, no integral will be above you. So let's go to the next. So in this video, I'll do this last one. Yes, I'll do this one. For the next video, I'm going to do in the next coming video, I'll do this. I'll do this too. Yes, and in another video, I'll do this, this, and this. You understand? Okay. So you should try already. Try to do all of them already. You should know what that I should do them. So let's do this last one. We have integral of 1 over 5 sine square 7x minus 6 cos square 7x. Is that okay? So let me go to the next page. So that's question how much? Question 3. Question 3, you have the integral of dx all over 5 sine 7x minus 6 cos 7x. 5 sine square 7x, pardon, minus 6 cos square 7x. Okay. Okay. Okay, let's then proceed. This is already identical as is identical to what? Integrating dx on what? A plus b sine square nx plus c cos square nx. You see that is the same thing. So the substitution we are going to do here is very simple. Our substitution naturally will be what? T being equals to what? Tan nx. So let's proceed. So our substitution here will be what? Let t be equals to what? Tan what? Tan nx. Our nx here is what? 7x. 7x. So let's directly find the x. This implies when I differentiate this, it gives 1 times dt. This will give dt being equals to differentiate this, I told you already, if I'm to differentiate tan 7x, it will be equals to, I differentiate this first of all, that is 7x prime, and I differentiate this one without taking into account. I behave as if this was, I behave as if they were asking me to differentiate tan u. So I'll have 1 plus tan square what? U, knowing that my u will be what? 7x. So this will be, I'll have 1 plus tan square 7x. Is that okay? So if you differentiate it using the chain rule, you have the same result. I've explained that already in previous videos. So the derivative of this, I'll have 7x prime into what? 1 plus tan square 7x. Since I was differentiating with respect to x, I'll write here dx. This implies dt. Let me wipe this other side. This implies dt will be equals to what? When I differentiate this, I have 7 into 1 plus tan square 7x times what? Dx, pardon, times dx. So this implies my dx will be equals to what? my dx will be equals to dt on what? 7 into 1 plus tan square 7x. You get what I'm saying? But remember, our t was what? T was equals to tan 7x. So this implies our dx, our dx will be equals to what? Dt on 7 into what? 1 plus tan square what? Let me replace tan. We have to replace the tan 7x by t, so this will make t squared. Is that okay? We have already our dt, we have already our dx, pardon. Now what are we supposed to find? We are supposed to find what is in our integral. When we will be doing the substitution, we are supposed to find what? Sine 7x and what? Cos 7x. Very good. So the next thing I will do, my substitution was t equals to tan 7x. That is tan 7x being equals what? T, which is t on 1, which is equals to opposite all over what? Adjacent. Okay, let me draw my right angle triangle. I'll draw my right angle triangle. Let me draw my right angle triangle. What's the angle? The angle is 7x. 7x. So I'll write it here, 7x. It is the angle of tan that I'm taking. My angle is 7x. What's the side that's opposite to 7x? It is this side. So the t, that's the opposite, will come here, and naturally 1 will be here. And we're going to have what here? 1 plus t square according to Pythagoras theorem. So this triangle ABC. Now, in my integral, I have to find sine 7x and cos 7x. Very good. So let's find sine 7x. Sine 7x will be equals to what? We shall use the triangle. We shall use the triangle. Sine 7x will be equals to what? Opposite all over hypotenuse. That is t on what? The square root of 1 plus t squared. I'll say from triangle ABC. Okay. My cos 7x will be equals to what? Adjacent over hypotenuse. So 1 on the square root of 1 plus t squared from triangle ABC. Very good. Now, having find the sine 7x and cos 7x, I'll first simplify this. I always told you, simplify this first before coming to substitute. I'll first find this. So I have to find, so this implies it's what? 5 sine square 7x minus 6 cos square 7x. So 5 sine square 7x minus 6 cos square 7x will be equals to what? 5 into what? This is my sine 7x, t all over the square root of 1 plus t square, all that square, plus minus 6 into what? Cos 7x, this is 1 all over the square root of 1 plus t square, all that square. Is that okay? This will be equals to what? This will be equals to, this will give t square, so I'll have 5t square on 1 plus t square minus 6 all over 1 plus t square. So this implies 5 sine square x, sine square 7x minus 6 cos square 7x will be equals to what? 5t square minus 6 all over what? 1 plus t square. So you have already what? Everything. You have already your dx and this. So this implies the integral of dx all over 5 sine square 7x minus 6 cos square 7x will be equals to what? will be equals to, I'll substitute everything. Integral of what? My dx was equals to what? My dx was equals to dt on the 7 into 1 plus t squared. So I'll put this dt on the 7 into 1 plus t squared all over this one was equals to this 5t squared minus 6 all over 1 plus t squared. This will simplify to this will be equals to integral of what? Dt all over 1 plus t squared times what? This is 1 on this, so this becomes 1 plus t squared all over what? 5t squared minus 6. This goes and this goes, so this will be equals, oh, don't forget that there is a 7 outside here, so 1 on 7, there's a 7, this dt, yes, there's a 7 dt here, don't forget. So this becomes 1 on 7 integral of what? Dt all over 5t squared minus 6. Be very careful. Be very, very careful. Don't make an error here and say that you will write it, you first come and write it in the form 1, that you will first come and write it in the form 1 plus something squared. This is not plus, this is minus. Be very, very careful. What you are to do here, what does this resemble? Which type of integral does this resemble? This simply resembles what? It's like we are integrating 1 dx on what? On ax squared plus bx plus c. This is what we are integrating. So what we have to do here is what? We basically have to find what? Delta. After finding delta, if delta is greater than 0, we will write it this as a product of what? 2 factors. Then express it in partial fraction and integrate. If delta is equals to 0, this will give what? Repeated root, real repeated roots. So we shall write it, this will be, we'll write it in the form an ax plus b all that squared, an x minus alpha 0, pardon, an x minus alpha 0 all that squared. You get what I'm saying? And we shall integrate that. You understand? And if delta is less than 0, what we are going to do is that we complete the square of this before integrating. So master well your things, master well your things. If you master well your things, you will see that integrating functions, integration is very simple. So let me write back this up there. So this will be 1 on 7 integral of what? Dt on 5t squared minus 6. Okay. We see that delta, let's find the delta of this. Let's find the delta of this. Delta, which is equals to b squared minus 4ac. Your examiner needs to understand what you are doing. Let's find delta for 5t squared minus 6. Okay. We see that delta is equals to what? B squared minus 4ac. Is that okay? So this will be equals to, our b here is 0. So 0 squared minus 4 into a is 5 and and c is what? Minus 6. So this implies our delta will be equals to what? This will give, this is 0, this and this will make plus. 6 times 5 is 30 times 4, this is 120. Okay, that's our delta. We see that delta is greater than 0. It implies this quadratic expression 5t squared minus 6 has 2 real and distinct roots. Is that okay? So let's find those roots. You can find the roots by either, let's find the roots, finding the roots of 5t squared minus 6. When they are asking you to find the roots of this, it simply means you are solving what? 5t squared minus 6 equals to 0. That's it, man. You can decide to use what? The formula, but there's no need of wasting time and using the formula here. This implies 5t squared will be what? 6, implying t squared will be equals to 6 on the 5. This implies t will be equals to plus or minus the square root of what? 6 on 5. I will write back this again as, because this is root 6 on root 5. I will rationalize it. This becomes, by multiplying top and bottom by what? Root 5. This becomes root 6 times root 5 all over what? Root 5 times root 5. Root 5 times root 5 is 5. This root a times root b is equals to root ab. So this becomes the square root of what? 30. So this implies our t will be equals to plus or minus the square root of what? It's a minute. Plus or minus the square root of 30 all over what? All over 5. That's our t. So since this is t, it implies that what? T is equals to what? Root 30 on 5, or t equals to minus root 30 on 5. So it implies this quadratic expression 5t squared minus 6 will be equals to what? This comes on this side, so it becomes t minus root 30 on 5 into this comes on this side, it becomes t plus root 30 on 5. So this integral, so it implies, let me draw a line like this, I don't want to get confused. So so it implies 1/7 integral of what? Dt all over 5t squared minus 6 will be equals to what? 1/7 integral of what? Dt all over what? This t minus root 30 on 5 into what? T plus root 30 on 5. How do you integrate this? To integrate this, what you are going to do is what? You express this, you first express this in partial fraction before integrating. So let's first express, always mention what you are doing for the examiner to understand what you are doing. So let's first express 1 on the t minus root 30 on 5 into t plus root 30 on 5 in partial fraction, in partial fractions, in partial fraction. So we know that 1 on the 1 on t minus root 30 on 5 into 1 plus root into t plus root 30 on 5. If you are to express it in partial fraction, this is identical. These are linear factors. So it will become a on what? T minus root 30 on 5 plus b all over what? T plus root 30 on 5. Is that okay? So this, so it implies, I'll look for the LCM. The LCM here will be natural. So let me copy back this 1 all over t minus root 30 on 5 into 1 plus root 30 on 5 must be identical to what? The LCM here must be the same as the LCM that will be here. T minus root 30 on 5 into t plus root 30 on 5. So this divided by this, I will have here a into what? T plus root 30 on 5 plus what? B into this divided by this, this one goes, and we'll have b into t minus root 30 on 5. Perfect. Now, if this expression is identical to this, since the numerators are already identical, it means the top must be identical to this. So this implies one will be identical to what? A into t plus root 30 on 5 plus b into t minus root 30 on 5. Now, we have to find a and b. There is no need of developing it. To find a, I will just, if I want to have a, I need to eliminate b. To eliminate b, I just need to let this t to be what? Root 30 on 5, and this will become 0. You understand? If I'm to find b, I'll just let this t to be what? Minus root 30 on 5 for this to become 0. So let's start by finding a. When t, since we're finding a, when t will be equals to what? If we equate this to 0, t equals to root 30 on 5. When t equals to root 30 on 5, what do we have? We have 1 being equals to what? This will become 0, and we'll be left with this a into what? This is root 3. This will be root 30 on 5 plus root 30 on 5. So that will make 2 root 30 on 5, implying our a will be equals to what? Our a will be equals to 5 on 2 root 30. Is that okay? So when x is equals to, we are now finding b. When x is equals to what? If you equate this to 0, that means t will be minus root 3 minus root 30 on 5. When I substitute it here, this becomes 0, and so it implies 1 will be equals to what? Our a becomes 0. Here we are going to have minus root 30 on 5 minus root 30 on 5. This gives minus 2 root 30 on 5, implying our b will be equals to what? Our b will be equals to minus 5 on the 2 root 30. So we have already our a and b. We have our a and b. We have to come and substitute it where? Inside here. We have to come and substitute it inside here. So this in partial fraction, let me go to the next page. So 1, so it implies 1 on t minus root 30 on 5 into t plus root 30 on 5 would be identical to what? To what in partial fraction? Would be identical to, here is it. Our a was what? Our a is 5 on 2 root 30, and our b is what? So I'll come and substitute this 5 root 30 here, and I'll come and substitute this minus 5 root 30 here. So this is, it's starting with t minus, okay. So this will be, our a was 5 on 2 root 30 all over what? T minus root 30 on 5 plus our b was minus 5 on 2 root 30 all over t minus plus root 30 on 5. Perfect. So let's rearrange it. This will be identical to what? This will be identical to 5 on what? 2 root 30 into what? T minus root 30 on the 5. Perfect. Minus 5 on what? 2 root 30 into t plus root 30 on 5. Is that okay? So since this and this are common, I'll factorize it. So it implies 1 on the t minus root 30 on 2 into t plus root 30. Oh, it's on 5. On 5 would be identical in partial fraction to what? 5 on 2 root 30 into what? 1 all over t minus root 30 on 5 minus 1 all over t plus root 30 on 5. Perfect. So we have already expressed this in partial fraction. That's the partial fraction form of this. So we shall take all of this and go and substitute it where in the integral where we have this. Let me go to the previous page. We were at this point. We saw that the integral of this was equals to 1 on 7 integral of this. So we have to continue at this stage. So this implies 1 on 7 integral of 1 all over t minus root 30 on 5 into t plus root 30 on 5 dt will be equals to what? Where I see this, I substitute by what? This. Is that okay? So that will give 1 on 7 integral of what? I'll copy the whole of this. So that will give 5 on 2 root 30 into what? Into 1 all over t minus root 30 on 5 minus 1 all over t plus root 30 on 5. All of this times what? Dt. So that's it. Is that okay? So the whole of this, we express it, the whole of this is it here. We express it in partial fraction as this. So that's why I substituted by this. Is that okay? Now, I'll bring this outside and I'll let the integral enter. So this will be equals to, this will give 5 on 14 root 30. Is that okay? 5 on 14 root 30 into what? The integral of 1 all over t minus root 30 on 5 dt minus the integral of what? 1 all over t plus root 30 on 5 times what? Dt. So we close these big brackets. You see that things are very easy. So just make sure to go through each of the videos. You will master well this integration. It's very simple. It's a very simple topic. So now, how do I integrate this? How do I integrate this? This is a linear function. This is a linear function. It's like they're asking you to integrate 1 all over ax plus b dx. We know that to integrate this, it simply equals to what? 1 all over what? Ax plus b prime ln of what? The absolute value of ax plus b. That's it now. Okay, I'm going to apply it up there. So this will become, don't be in a haste when you are doing your integrals, because if you do errors, you will not have the answer. So this will be equals to 5 all over 14 root 30 into what? The integral of this, which gives 1 all over what? T minus root 30 on 5 prime ln of what? The absolute value of t minus root 30 on 5 minus what? I integrate this minus, this will give 1 on what? T minus plus root 30 on 5 prime ln of the absolute value of t plus root 30 all over what? 5. Don't forget plus the constant of integration where k belongs to r. Is that okay? So this will be equals to what? 5 on 14 root 30. When I differentiate this, there is t here. When I differentiate this, this is simply 1. So I will be left with ln of the absolute value of t minus root 30 on 5 minus, when I differentiate this, this is simply 1. Ln of the absolute value of what? T plus root 30 all over 5. Now, what do you have here? You simply have ln of a minus ln of b, which is equals to what? According to laws of logarithms, ln of a, ln of what? A on b. So so this, I'll simplify it again, as this will become 5 on 14 root 30. I'll apply it here. So this will become ln of what? Absolute value of t minus root 30 on 5 all over what? Absolute value of t plus root 30 on what? 5. You get what I'm saying? Since there is an absolute, this is another rule. The absolute value of a on b is equals to the absolute value of a all over the absolute value of b. So I'll apply it here. So this will be equals to, this can still be written in the form 5 on what? 14 root 30 ln of what? Oh, there's a constant of integration here, plus k. So this ln of what? The absolute value, we apply this rule. Absolute value of what? T minus root 30 on 5 all over what? T plus root 30 on 5 plus our constant of integration. But remember something. Our integral was given in terms of what? X. So we are supposed to leave our answer in terms of what? X. Now, what was the relationship with t with x? If you can remember, at the beginning, our t was equals to what? Tan 7x. You get what I'm saying? Our t was equals to tan 7x. So I'll go back to my integral. I'll write this, but recall that t was equals to what? Tan 7x. So where I see t, I substitute by what? Tan 7x. So this implies the integral of dx on the, what was the integral we're asked to find? On the 5 sine square 7x minus 6 cos square 7x. So the integral of 5 sine square 7x minus 6 cos square 7x will be equals to what? Where I see t here, I replace by what? Tan 7x. So this will give 5 on 14 root 30 ln of what? The absolute value of what? Tan 7x minus root 30 on 5 all over what? Tan 7x plus root 30 on 5 plus what? Our constant of integration. So that's the integral we were asked to find. So you see that it's very simple. Very, very simple. Just know, master what has been taught to you. Master everything. Don't skip any of my videos. Don't skip any of my videos, because if you skip any of my videos, you will not understand things we are going to do in front. Don't skip any of the videos. Don't skip it. So that's very simple integral. You were asked to calculate. So that's all for this. The video is already more than 1 hour, so it's not a big deal. So just try to go through this video in a very keen way for you to understand what has been done. So in the next video, I will do this and this, and I will complete it by also proving this, because we know already that the integral of sec theta will give us ln of sec theta tan theta. We shall also prove that ln of sec theta tan theta must be equals to what? This. So you should remember these two forms. For the other integral cosec x, we know that the integral of this is ln of what? The absolute value of cosec x minus the integral of this will give ln of the absolute value of cosec theta minus what? Cot theta. We shall also prove that ln of the absolute value of cosec theta minus cot theta must be equals to what? Ln of tan what? Theta on 2. You get what I'm saying? So in the next video, I'll do these two integrals. So we saw that basically on these two integrals, our substitution was t equals what? Tan n theta. This is 3x. So you are going to try this other one. This is also 3x. So try to do this integral to exercise yourself. So see you in the next video where we are going to see how to do this and this. And in the last video, we shall do this, this, and this. Okay. So see you in the next video.